Okay, I'm going to do a few of the word problems here from page 462. And with these word problems, all I'm going to do is the basic setup. I'm going to read it and draw the picture. And then I'm assuming you guys can do the sine, cosine, tangent to help solve the problem. So I'm going to start with number 28 here. It says elevation. I'm reading from the book. Two hills are 2 miles apart. The taller hill is 2,707 feet high. The angle of depression from the top of the taller hill to the top of the shorter hill is 7 degrees. Find the height of the shorter hill to the nearest foot. Okay. So, of course, angle of depression, you've got to have a horizontal and then looking down. So this is 7. Don't make 7 here where my pen is pointing to. That is not 7 degrees. At any rate, one of the things we're going to do is convert this miles, 2 miles apart between the hills, to feet. So 1 mile is equal to 5,280, so just simply multiply by 2. You get 10,560 feet. This is going to require two things here. To figure out the height of the small hill, we are going to first worry about the difference between the tall hill and the small hill. Okay, that will be the number one thing here. Hopefully you can see this right triangle there. And we're going to figure out this x, because that's the difference between the tall hill compared to the small hill. And if we can figure out x, then we would simply take 2,707 feet and minus out x, and that will give you the small hill. So, first thing we're going to do is try to figure out the x. Okay, again, this is 10,560 feet, which is right here, 10,560 feet. So if you look at this yellow right triangle here, we've got 7 degrees, opposite, adjacent. That is tangent of 7 degrees is equal to opposite x over adjacent 10,560 degrees. Now once you solve for x, you're not done, because you actually want to figure out the height of the tall hill. So you take, the small hill. So you take tall hill, minus out the difference, and you get small hill. So the tall hill we know is 2,707. The difference, we're going to minus the difference, which is x. We'll figure out what x is in a moment, and then you will get the answer, the difference of the small hill. So you got to solve for x. Once you know x, then you can solve the height of the small hill. Number 28. All right, I'm going to do number 29 here. I'm going to first read it. It says, surveying. A surveyor is 305 feet from the base of a new courthouse. So I kind of drew this scenario here. Here's a courthouse. Here's a person's a surveyor. And this person is 305 feet from the base of the courthouse. Her angle measuring device is 5 feet above the ground. So this is a person here. This is a measuring device, and this is 5 feet above the ground. The angle of elevation is at the top of the courthouse. So she looks through this thing. It kind of sees the top. There's the horizontal. The angle of elevation is 42 degrees. And then we want to figure out the height of this courthouse. Now, this is 305 from the measuring device to the courthouse. So that's 305 here. 305 feet. Here is the right triangle that we are going to have. And there's one extra step. Now we want the height of the courthouse, so that's x, which is right here. But if you'll notice, this yellow triangle is not really on the ground. It's actually 5 feet above the ground. So, because that's the machine is not on the ground, it's 5 feet above it. So this right here is 5 feet right here. So what we're going to do is solve for x, and then we're going to add 5 feet to it to get the height of the courthouse. If I look at this, this is adjacent and opposite, so we're going to say tangent of 42 is opposite over adjacent. And then to figure out the courthouse building, the courthouse, we would take x, and then we're going to add 5 to it, because again, this x is the majority of the courthouse, but then again, you've got to recognize the fact that it is 5 feet above the ground. So solve for x, and then add 5 more feet to it. All right, and one final word problem that we'll just draw the picture. It says, number 30, indirect measuring. Linda is flying a kite. So there's a kite here. and she lets out 45 yards of string and anchors it to the ground. So that's a string, it's 45 yards, and she anchors it to the ground. The angle of elevation she determines the angle of elevation of the kite is 58 degrees. So the angle of elevation up to the kite is 58 degrees. What is the height of the kite from the ground? So that means just straight up and down, what is this height here? That will be x, and that's essentially your picture there. So obviously you can see the right triangle here. Starting at the angle, that's opposite, that's hypotenuse. So you would say sine of 58 is equal to opposite x over hypotenuse 45. The height from the ground. Number 30.